Hello. To classify polygons, we need to understand what the meaning of polygon. A polygon is a simple closed figure formed by three or more line segments. Each line segment called a side. The figures here are not polygons because the first one contains a curve and the second one contains an overlap between two sides and the third one is not closed. If the polygon contains three sides, it's called triangles. Four sides quadrilateral, five sides pentagon, six sides hexagon, seven sides heptagon, eight octagon, nine nonagon, 10 decagon. The first side here is a polygon, or the first shape here is a polygon because it contains six line segments, no curves, and no overlap, and it's closed. So it's a hexagon. But the second one doesn't represent a polygon because it contains a curve. To find the summation of the interior angles of a polygon, we need to use the formula of n minus 2 times 180. The shape here represents a pentagon, and we have learned earlier that the summation of all the interior angles of a triangle is 180. So if I want to find the summation of the interior angle of the pentagon, I can cut it to three triangles. Each one of them is 180. So I can multiply 3 times 180 to find the summation of the interior angles of the pentagon. Or I can say that 5, because the number of sides here are 5. 5 minus 2 times 180, so gives you 3 again times 180. Find the sum of the measures of the interior angles of a nonagon. We know that the nonagon contains 9 sides. So n here is 9. I write first the formula n minus 2 times 180. And then I replace n with 9. So 9 minus 2 times 180. It's 7 times 180 equals 1260 degrees. So the summation of all the interior angles of a nonagon is 1260 degrees. A diagonal cuts any pentagon to a number of triangles. So if I have a square, the square contains four sides and it cuts it to two triangles. So again, n minus 2. So the diagonal is the line segment that joins two non-consecutive vertices in a polygon. In the pentagon, it cuts the number of diagonal cuts are 2, and it cuts the pentagon to 3 triangles. So if it's 5 sides, so it's 5 again minus 2 to give it 3, 6 minus 2 for the hexagon. And for the octagon, I have 8 sides, then 6 triangles. So the number of triangles is 2 less than the number of sides of any polygon. A regular polygon is a polygon that has all sides congruent and all angles congruent. Since the angles are congruent, their measures are equal. An example for this is following. The surface of a football contains 12 regular pentagons and 20 regular hexagons. What is the measure of one interior angle of a hexagon? To find the measure of one interior angle of a hexagon, I need to find the summation of all the interior angles of the hexagon and then divide it by the number of angles in the hexagon because all of them are the same or all of them are congruent. So I will write here the formula to find the summation of all the interior angles of the hexagon. So it's n minus 2 multiplied by 180. For the hexagon, yeah, it's the hexagon. So for the hexagon, n here is 6. So 6 minus 2 times 180. 6 minus 2 is 4 times 180. 4 times 180 is 4 times 0 is 0, and 4 times 8 is 32. 4 times 1 is 4 plus 3 is 7. So we have 720. This number represents the summation of all the interior angles of the hexagon. But we need to find the value of one angle. So I still need to divide 720 by 6 because the regular hexagon contains 6 congruent angles. So I'll divide it by 6 to get 120 degrees for each. That was everything today, and thank you for watching.